Hello everyone, I am Christian and I should be presenting the paper titled Towards a Hybrid Verification Methodology for Communication Protocols, written together with Adrian Francalanza and Alcestis Calas. Let's start by defining the problem that we identified. Consider a simple client-server scenario as shown here, and assume that we are developing a login server which can be accessed by different clients whose code we do not have access to. If the clients conform with the protocol, we can guarantee error-free communication between the parties. This is the communication protocol that the server and the client must follow. The client initializes communication by sending a login request, including a username, a password, and a token. If the credentials are valid, the server replies with a success, including a session ID, which is then used by the client for further requests. Otherwise, if the credentials are invalid, the server sends retry, and the client can retry by sending another login request. Down at the bottom, one can see how we formalize the server side of the protocol using session types. Session types allow us to describe the behavior of the participants. The formalization is very intuitive. As we said, the server receives a login request, shown here with the question mark, and then depending on whether the credentials are valid, it sends either success or retry, shown here with the exclamation point. If it sends retry, the session recurses and the protocol starts from the beginning. This is the client side of the protocol, which is the dual of that of the server. Basically, it states the opposite behavior of the server. Where the server receives a login request, the client sends a login request. And similarly, when the server sends success or retry, the client can either receive success or retry. Through this formalization, we can reason about the behavior of the two parties. The question now is, how can we enforce such protocols on the two parties? We have the server, the client, and we also have the expected protocols they should follow. However, we do not know how we can enforce such behavior. One approach would be to go with full dynamic analysis, in which the monitors would sit between the client and the server and analyze the messages communicated by the two. And in the case that either one violates the protocol, the respective monitor would raise a flag indicating the violation. However, the problem with such approach is that dynamic analysis cannot guarantee that the server is implemented according to the session type. The monitor can only detect communication errors, and it cannot guarantee the absence of such errors. And this is not sufficient for us, as we want to ensure that the server is actually implemented according to the protocol. The second option would be to go with full static analysis of the participants, whereby we assume that we have a static analyzer, which, given the implementation of the two participants, together with the protocols they should follow, it would tell us whether they conform with the protocol or not. However, in our case, we do not have access to the implementation of the client, and therefore we cannot use such static analyzer. And as a result, we are back to where we started. We have the two protocols, we have the implementation of the server, and we want to ensure that it conforms with the protocol, and also we want to ensure that the client follows the protocol. However, we do not know how. And in the following slides, I shall outline how we managed to achieve this goal. And this is what we propose. We marry the two approaches, static and dynamic analysis, together to form a hybrid verification of the protocols. In this setting, a monitor sits between the two parties. One side of the protocol is statically checked at compile time, while the other is dynamically checked at runtime by the monitor. Given the expected protocol the server should follow, the monitor is synthesized by a synthesizer. This monitor acts as a proxy between the two participants. meaning that messages sent from the server to the client are first sent to the monitor, which then forwards it to the client and vice versa. Apart from this behavior, the monitor has two other important roles. The first being that it serves as the dual endpoint of the server, mimicking the behavior of the client. This is a way for us to guarantee that the server is correctly implemented, as the implementation of the server and of the monitor are now passed through the static analyzer mentioned previously, together with the protocols that they are expected to follow. If the result of the analyzer is positive, we are guaranteed that the server follows the expected protocol. Otherwise, it does not. This is the static part of the hybrid verification approach. The second important role of the monitor is that it dynamically analyzes the messages sent by the client. All messages sent by the client are first analyzed by the monitor, and if they violate the protocol, the monitor raises a violation. Otherwise, it would forward them to the server. Before proceeding, let's recap our proposed design. Given the protocol of the server, the synthesizer synthesizes a monitor which sits between the server and the client, forwarding messages sent by each of the parties. The implementation of the monitor and the server are passed through the static analyzer, which tells us whether the server violates the protocol, and if not, guarantees that the server is implemented according to the protocol. Also, the monitor dynamically analyzes the messages sent by the client at runtime, with the aim of detecting any violations of the expected protocol, therefore protecting the server from any violating messages. This is how we implemented our proposed design. We used the Scala programming language throughout, except for the external case, which in this case being the client. And we assumed that this side of the protocol can be implemented in any programming language. The protocol that the server is expected to follow is passed through our synthesizer, which generates a runtime monitor and a set of protocol classes. These protocol classes serve as a representation of the protocol within the Scala programming language. The interaction between the server and the monitor is handled through a Scala library named lchannels, which, given the implementation of the dual participants and the protocol classes synthesized by the synthesizer, leverages the Scala compiler to ensure that the participants follow the protocol. On the other side, we do not pose any restrictions on the interaction between the monitor and the client. However, we do assume that we have a user-supplied library named Connection Manager, which is shown as CM, whose job is to translate messages to and from the particular formats and also handle the interaction between the monitor and the client. And that is basically how we managed to achieve the hybrid verification of the protocols, in which the accessible participant is statically checked at compile time, in this case the server, and the other inaccessible participant is dynamically checked at runtime. Since the monitor acts as an intermediary between the two parties and has access to the messages being sent, we can actually augment the protocols by adding assertions. If we recall the protocol that the server should follow, which is shown here, assertions would look something like this. The assertions allow us to control the conditions under which interactions may be done. In this case, when the client sends a login request, the monitor invokes a user-supplied function named as valid token with the values of the username and the token, and checks whether the token is valid or not. If it is invalid, the monitor raises a violation. Otherwise, the monitor would forward the message to the server. Similarly is done when the server sends success, in which the session ID is validated. To further explain our approach, I shall go through a couple of examples. To start with, we generate the monitor by passing the protocol to the synthesizer. The synthesizer ensures that the protocol is written correctly, and it synthesizes the protocol classes and the monitor. The implementation of the monitor and the server using the library lchannels are passed to the Scala compiler together with the protocol classes, and since the result of the compiler is successful, we can ensure that the server conforms with the expected behavior. Next, we develop the connection manager, which translates HTTP requests to the format used by the server and the monitor, and vice versa for the HTTP responses. And then we deploy the server. Then a conforming client arrives. It sends an HTTP post login request, including the username, password, and the token. The monitor retrieves the translated message by the connection manager, and since it conforms with the protocol, the monitor extracts the contents and passes them to the function valid token, which in this case returns true. And therefore, the monitor forwards the request to the server. The server processes the request, and the credentials supplied by the client are correct, and therefore the server replies with success, including a session ID to the monitor. Similarly, the function validID is invoked with the username and the ID of the client, which checks that the session ID sent by the server belongs to the particular user, and it also returns true. And therefore, using the connection manager, the monitor translates and forwards the response to the client, and the participants may continue accordingly. Let's assume now that a client arrives which is implemented incorrectly. This client sends a login request including only the username and the password without the token. Once translated by the connection manager, the monitor analyzes the message contents, and since it does not conform with the expected protocol, it flags a violation and the session terminates there. And that sums up our hybrid approach. This is how we plan to proceed with our research. Basically, first we plan to investigate the monitorability properties of our approach with the aim of identifying any limits of what can be verified at runtime. Secondly, here we only considered interaction between two participants, and we plan to extend our approach for multiple interactions between 3 or more participants. Furthermore, we also want to investigate how to handle assertion violations by adding compensations to our session types, which formalize how the protocol should proceed when a violation is flagged. Finally, to summarize this presentation, our goal was that we wanted to enforce communication protocols between accessible and non-accessible parties. As we said, dynamic analysis is not sufficient for our needs, and static analysis cannot be considered in our case, and therefore we married the two approaches into a hybrid verification methodology, which entails synthesizing a monitor according to a session type. Finally, we gave an outline of how our methodology is implemented in the Scala programming language and based on the library lchannels. Thank you very much for your attention, and now it's time to take any of your questions.